Sure.
It's all yours, Piyush. Thank you.
All right. Yeah, sure. Thank you, Raguraj. Hello, everyone. Good to see you all. And just to introduce myself to start with, my name is Piyush Bothra, and I'm Solutions Architect. Been with AWS for about almost 3 years now, and enjoying every bit of it, as this role gives me an opportunity to get in front of customers, talk about AWS services, and help solve their challenges with respect to technology and help them innovate. Um, so I'm with AWS for almost 3 years now. Prior to that, I was with IBM for around 10 years, and then I was with another telecom company for 3 years. But mostly my experience has always been around architecture leadership, software architecture, IT architecture leadership, providing guidance with respect to architecture modernization, not necessarily on cloud, but across the board. So I started my journey on cloud just about almost 3 years ago. So when I joined AWS, I did not have much experience of working on any cloud. However, I did have some experience, architecture experience in on-premises environment. That kind of helped me, but I'm still learning when it comes to cloud technology because we innovate almost every day, right? And we innovate on behalf of customers. So as we understand customers' problems, challenges, we try and solve them in various ways. Some challenges are something which were never addressed before. So we provide that feedback to our service team so that we can fill those gaps in our services if there are any gaps. So that's how that's kind of one side of the role of being a solutions architect at AWS. With that, and then from personal point of view, I'm a big sports fan. If anyone of you is from India or any other country where cricket is played, I'm a big fan of cricket sports, and I like playing golf as well. That's another of my hobby. Love listening to any kind of music, especially Bollywood music, and then just love hanging around with friends and family. I have two kids. One has just started in high school. My daughter, who is in ninth grade, and then my son is in seventh grade. And I'm based out of South Florida, so about 45 miles north of Miami, Florida, in USA. So that's a bit about me, but would love to share more experiences if you have any questions. But as you're starting your journey in cloud, one of the which I started, especially when it comes to cloud, just about 3 years ago, right? So not that far away. But I would also always say that the technology is changing so much. One piece of advice that someone had given me, which I always keep very close to me, is that keep your mind open to learning anything which comes new, and which always has helped me. Even working on AWS, depending on customer, sometimes it's database area that we need to focus on, but some other time it's machine learning that we need to focus on. So that's kind of fun part as well, but a challenging part as well, that how much are you going to learn. But so, just keeping your mind open to learning new things, be curious about new technology. That is one thing that has always helped me. So today's topic is creating custom VPC on AWS. So the way I plan to approach it is I'm going to show a few slides talking basics of networking, what VPCs are, what subnets are, and how they come together with respect to AWS infrastructure, regions, availability zones, right? What is the importance of each of those components, so that when I start demoing how to create a custom VPC, it kind of makes more sense. I'm sure you all have gone through your education or your training where some of these is covered. So I would like to keep it interactive. If you have any questions, feel free to stop me in between. I will try and take a pause in between, because if you interact with me, I would know how deep I want to go or how detailed I want to go in any of those areas. Make sense? So any questions, any comments before we get started? All right. If not, then we can get started. So let me ask you this thing, raise your hands or just ping or chat in the chat. How many of you have created a custom VPC before? If you have created a custom VPC, just say yes in the chat. So none? All right. That helps because now I would focus more on basics, and then I'll focus more on demoing how to do that. Have any of you gone through basics of VPCs and what VPCs are? Have kind of even theoretical understanding of the components of AWS infrastructure, including VPCs and subnets? I think Osaji, if I'm pronouncing your name correctly, you're trying to speak.
Yeah, sorry, I was just saying yes, of course. Can you hear me?
Yeah.
Hello? Uh-oh. All right, yeah. Sorry, I was just saying, yeah, of course. You're asking if we, familiarized with the whole VPC concept and all of that. Yeah, definitely. I'm familiarized with VPC, reason why.
Okay.
So, yeah.
Awesome. Yeah, so feel free to interrupt me in between to ask any detailed question as well around any topic. We'll be more than happy to answer it. Sneha, you have something that you wanted to say? Okay, let's get started then. So I'm going to share my screen and I'm going to share the presentation that I'm going to go through today. A second. Do you see my screen? Okay. Raguraj, do you see the presentation screen with networking in AWS?
Yes, I can.
Okay, awesome. All right. Yeah. Sometimes what happens is that when I share the screen, it's my notes screen that gets shared and not the presentation mode. So that just wanted to make sure.
Right.
All right. So yeah, I'll turn off my video for now so that we don't run into bandwidth issue. Hang on one second. Okay. All right. Okay. All right. So let's get started. I would like to cover some of these topics today: regions and availability zones, VPC overview, subnets, availability zone, NAT gateways, multi-AZ best practices. Just some of these topics, just as a refresher. But then I'll also give a kind of demo on process of creating a custom VPC And then as we go through the demo, I'll touch upon some of these components as well, so that you're comfortable creating a new VPC on your own, and you know what options to select when, depending on the use case. So as a refresher, right, let's do a quick infrastructure overview. So first, within AWS Cloud, we have regions like US East 1 region, which is somewhere in North Virginia. And then within the region, we have at least 2 and usually 3 or more availability zones or AZs. Each AZ has 1 or more physical data centers. And then AZs are interconnected by redundant, low latency, high bandwidth links in a mesh topology. So this speed supports synchronous replication and other high availability scenarios. We also have other regions like US East, US West 2, which is in the Oregon. These are also connected by redundant links to other regions. So basically, within a region, we have availability zones, at least 2 availability zones, and most of the new ones have 3 availability zones now. The connection between availability zone is redundant, right? Low latency, high bandwidth connection. And then there are multiple regions. So connection between region is also redundant, and they're linked with each other in AWS backbone. Okay, so then let's talk about VPC and how it fits into the regions and availability zone concept. So we have AWS Cloud, right? And then you have within an AWS Cloud, when you start, right, you'll need to create an account, right, which is your AWS account, which you use to log in into the console. Now, within an account, you choose a specific region, example, US East 1. Now, you can set up your AWS resources in multiple regions, but for now, let's look at one region, let's say US East 1 within that account, right? And then within a region, you can create your virtual private cloud or VPC. Now, this virtual private cloud is, think of it as an isolated networking construct or a data center that you for yourself that you create in AWS Cloud. So any connection to this VPC or outside of this VPC is not happening without you configuring that connection. So this is an isolated infrastructure that you have created in AWS Cloud. A VPC can span multiple AZs in one region. Okay, so you create a VPC in a region, and then within that VPC, you can have your infrastructure built on multiple availability zones. All right, and there are certain services known as regional services where they live outside of your VPC but are tied to a region, like Amazon S3. So when you create a bucket in Amazon S3, for example, you don't define an availability zone or a VPC that bucket belongs to, because it is not created, or it is not a VPC construct. This is a public service which AWS provides, right? And so there are certain services like Amazon's S3 and Amazon DynamoDB, which are not launched inside a VPC. But then there are services like Amazon RDS, which is a database service, or Elastic Load Balancer, or your EC2 instances. They become part of your VPC or your isolated network that you have created within AWS. A small number of services are considered global services. This includes your identity and access management, IAM, which helps control access to your resources. Okay, and some services are regional services like Amazon S3 and Amazon DynamoDB. So just to recap, right? You have some of the infrastructure that you're going to create, like EC2 instances, Amazon RDS databases, that will become part of your VPC. Okay, some services are regional services, which are not part of your VPC. They are public services, right, which you can access using the APIs that they provide. They are regional services like Amazon Simple Storage Service S3 and Amazon DynamoDB. And then there are some services which are still outside of VPC, and they don't even belong to region. They are more of a global services like AWS IAM and Amazon Route 53. Any questions so far? Okay, so we'll continue. Now, let's focus a bit closer on your VPC. When you create a VPC, you must choose a private seeder, right? Which we call as, which are nothing but range from which private IPs will be assigned to resources that you create. The full form of that is classless interdomain routing, also known as supernetting. It is a set of Internet Protocol or IP standards that is used to create unique identifiers for networks and individual devices. The IP addresses allow particular information packets to be sent to specific computers. So basically, when you create a VPC, you have created, but then these VPCs, any infrastructure that you create within that VPC, that will be associated with IP addresses belonging within this CIDR range. Now, before you can use your VPC, it also needs subnets, which are partitions of your networking space. Right, so this range of IP addresses, which is a CIDR routing blocks that you have created, you're going to divide them into multiple subnetworks, which are called subnets here, right? So for this example, which you're showing in the slide, we create two subnets. First has 10.0.1.0 range, and another has 10.0.2 range. Now remember, a VPC lives in a region and can cross multiple availability zones. But it is very important to note that a subnet is tied to only one availability zone. So a single subnet cannot belong to two availability zones. All right. A single availability zone can have multiple subnets, but a subnet can only belong to one availability zone. Hope it makes sense. It will make more sense with this picture. If you look at this picture. So VPC is in a region. Within a VPC, you have multiple subnets. Each subnet belongs to an availability zone. And then, one second. Okay. And now, so for example, our first subnet is in US East 1A. Our second is in US East 1B. Once you have subnets, you can launch resources in them. For example, here in this slide, you see EC2 instances, which are belonging to subnet 1. And then you have your database, Amazon RDS instance in subnet 2. Now, another networking construct is route tables. A route table contains a set of rules called routes that are used to determine where your network traffic from your subnet or gateway is directed. There are many different types of route tables. Route tables are like, think of them as establishing a road between two cities. On top of that road, you can add roadblocks such as security groups to establish that traffic is allowed to cross the road. So basically, you've created your infrastructure and EC2 instances in your subnet and availability zone. Now, you want to make sure that those EC2 instances communicate with other infrastructure components based on the requirements, right? How they connect to other infrastructure components will be defined by a route table. So route table will create that bridge between those infrastructure components. So a main route table is a route table that comes automatically with your VPC. It controls the routing for all subnets that are not explicitly associated with any other route table. And then the association between a route table and a subnet, internet gateway or virtual private gateway, is done by a subnet route table. So a route table that is associated with a subnet. So every subnet must have one and only one route table attached to it. A subnet can only be associated with one route table at a time, but you can associate multiple subnets with the same subnet route table. Hopefully, I'm making sense. If you cannot visualize a practical use of that, feel free to interrupt and ask questions, and I'll try and provide an example to explain it. So the route table contains one or more rules that determine where to send traffic that originates from these associated subnet. In this example, subnet 1 and subnet 2 share the same route table, which is on the right-hand side. Every route table comes with a special default rule. So if you look at the route table rules, right, you will see destination and target. A target is the gateway or the network interface or connection through which to send the destination traffic. And then local route is a default route for communication within the VPC. So in this example, the destination is the VPC CIDR that we had defined, and the target is a reserved word called local, right? This means that any traffic with a destination matching the VPC CIDR block will be routed to the appropriate instance within the VPC. So when we say target is a local, that means target directed within that VPC, and then destination will define what is the IP address or range of IP addresses where you want traffic to go. Okay. Now, if an instance tries to reach a resource outside of our VPC, but there is no route, the packet gets dropped by the VPC. So understand this. You have defined a subnet. You have associated a route table with that subnet, right? The route table decides where and how the traffic from within that subnet is directed, right? If you have target as local, then the traffic will always get directed within that VPC only. It cannot go to internet because only the local traffic is allowed out of that. However, if you want an internet connectivity, or if you want your EC2 instance within that subnet to connect with internet, then you will need to attach an internet gateway. All right, and just because an internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between your VPC and the internet. Okay. Now, just because you have created an internet gateway does not necessarily mean that we have an internet access, right? What you'll need to do is, just like you did it for, you added a rule in your route table for local traffic, you'll need to add another rule in your route table where the target would be that internet gateway, which you see here in IGW12345, that's your internet gateways, and your destination, which is your public network outside of your VPC or internet. Now, when you attach the internet gateway to that subnet route table, then that subnet which is attached to the route table will have capability to access internet or talk or go outside of your VPC. Any questions?
So Piyush, does it means like, so the route table will decide like which packet should enter to that subnet?
The route table will decide, think of route table as a road, right? Or a bridge between the source, right? Which is the EC2 instance within the subnet here, and what component or what infrastructure, or who does that EC2 instance wants to talk to, right? So in this route table will direct the traffic from your subnet to that destination.
Okay.
So if an EC2 instance, let's say if you have a web server in that EC2 instance, right? Okay. And you would want, obviously, if it's a website, right, then you would want that website to be on internet, right? And then anybody should be able to access that website.
Yeah.
However, if you do not have an internet gateway route rule associated with the route table, then those packets are not going to internet, right? So they will not be able to access your website.
Okay. Yeah.
Okay. However, if it's not a web server, and let's say it's a database which is in your EC2 instance, then you don't want your public, or you don't want the database to be accessible via internet, right? Because usually you wouldn't want that. So in that case, you will not attach or you will not create this rule of internet or attach an internet gateway to that subnet where the database resides. You will only create that local route where the database should be able to communicate with the resources within that VPC and not outside of that.
Okay.
Make sense?
So, so we will be creating a second route table. Like if we are having a website which we have a database also, but it cannot be accessed by public, like the database, but the website should be accessed by public.
Right. So yes. So in that case, what you do is, hang on one second. I think I have a slide for that. Let's use this slide. In that case, what you do is you put your, you create two subnets. One is public subnet and another is private subnet, right?
Okay.
In the public subnet, you keep your web server, right, which is accessible by internet. And the reason it is a public subnet is because you have internet gateway attached to it.
Yeah.
Okay. And then you put your database in private subnet.
Okay.
Because, and that private subnet will not have internet gateway attached to it. So the only traffic which can go from there is locally within that VPC.
Okay. Yeah.
Sounds good?
Yeah.
Okay. And then you can have, there is one route table attached to private subnet and another route table which is internet gateway rule attached to the public subnet.
Okay. Yeah, it makes sense.
Okay. Any further questions?
No, not at the moment.
Okay. So what I'll do now is we have talked through region, availability zones, subnets, right, and VPC, of course. Let's go to the demo and create a VPC, and then we can, if needed, we can come back here. All right. So I'm going to open a browser here. 1 second. Okay. Do you see my browser or my AWS console?
Yes.
Okay. So I've logged into my AWS console. All right. I'll go to VPC. All right. And so there are two ways you can create your VPCs. Either you click here on VPCs and then go create VPC, and it will just ask you for your VPC name, CEDAR block that you want to use, and then create VPC, right? And then once you create that VPC, you can create subnets, security groups, availability zones, all those things within that VPC. I'm not going to do that. What I'm going to do here is I'm going to use this VPC wizard, launch VPC wizard, right? Just to keep things simple here. In this left-hand side, you'll see multiple options of creating VPC. One is VPC with a single public subnet. Another is VPC with public and private subnet. Another is VPC with public and private subnet and hardware VPN access, right? So let's create a VPC with public and private subnet. Okay. I select that. Here you go. So now the first thing it's asking me, like we have said, right, when you create a VPC, first you'll need to define a CEDAR block to assign the range of IP addresses available for that VPC. So let's keep it as 10.0.0.16. I'll give a VPC name. Let's give it a restart. Now, because we have selected an option to create one public subnet and one private subnet, it has automatically given me this option to equally distribute the IP addresses range between those two subnets, right? So here you will see 10.0.0.0/24 and then 10.0.1.0. So what that means is that it will keep 255 IP addresses available for public subnet and 251 IP addresses available for private subnet. You can pick an availability zone, optional, where you want the subnet to be in. Remember that a subnet has to belong to one availability zone. A subnet cannot span multiple availability zones. All right. So, okay, let me assign US East, this subnet to US East 1A, and then private subnet I'll assign to US East 1B availability zone. Okay. And now here, one thing to remember is because I have selected a private subnet, right? It is asking me to attach a NAT gateway, NAT gateway here. Now, anyone knows what NAT gateway is?
So it's basically a network address translator. So which translate the IP address.
Yeah. Okay. I'll just wait for her to finish if you want me to input.
Yeah, sure.
Okay. All right. Yeah. NAT gateway is this is, well, like she said, network address translation gateway. Basically, it helps. For example, if you have resources in your private subnet, then the NAT gateway is what helps to translate those private addresses to internet routable addresses to go through the public subnet and out to the internet.
Awesome. Yep. Exactly. So if you see here, right, let me create a NAT gateway and I'll just give it a name, restart 1, and I'll not attach this NAT gateway right now. So create a NAT gateway. Oh, okay. Let me Actually, let me just try and attach. Yeah, so you're right. So NAT gateway, basically what it does is when you have resources in your private subnet, and if you want those resources to still access internet without keeping it all open, right, for a specific use case or a specific purpose, then you can route the traffic from that private subnet to NAT gateway, and that NAT gateway will help you drive the traffic to internet for specific purposes. Okay, so I'm going to use this network gateway ID here. Let's see. Okay. So let's come back here 1 second. Let's skip this create creation ID, elastic IP. Okay. Let's create an elastic IP address. Okay, there you go. So because when you create, it wants to create a NAT gateway, and NAT gateway has to be associated with an elastic IP address so that, because it's public endpoints, create VPC here. Now, what it's going to do behind the scene is it's going to create a VPC for you. That VPC has one public subnet and one private subnet, right? With one subnet in availability zone US East 1D and another subnet in availability zone US East 1C. So this is something that it will create behind the scene for you, and it will also create a NAT gateway in that public subnet so that an instance and private subnet can still go to internet via that NAT gateway. And obviously the public subnet will have internet gateway attached to it. So it will create all these constructs behind the scene for you. Now, you don't necessarily need to use this VPC wizard. If I had come here, right, to VPC dashboard, and if I had just gone here and create a VPC, right, I could have done that as well. And let's name it restart true, right? And it will still create that VPC. Let's see, 10 start. It will still create that VPC. Okay. Here, look, restart to, it has still created that VPC, but there are no subnets and internet gateway and, already assigned to this VPC. Then you'll need to manually go ahead and create a subnet, right? And then in that VPC, and then attach an internet gateway to make a subnet public, and then have a NAT gateway created separately. So you can still, you'll need to do all those steps, which is done behind the scene for you using this wizard. You'll need to do them step by step manually. So here, using this wizard, our VPC is created. You see two VPCs here, right? One is restart, which we created using that wizard, right? And it should have the Cedar block as we defined 10.0.0.16, right? And if you go to this VPC resources, you will see all those subnets, the two subnets that we have created, and the internet gateway associated. So let me go to this this VPC here. Okay. And if I go to subnets, one second, you see in the subnets section here, if you click on this subnet, and where is the VPC associated with it? Here. If you click on this subnet and right, and if you see VPC associated, you see this restart, right? So that's a public subnet created by VPC wizard, and it is associated with this VPC. The same way, there is a private subnet here, and if you look at VPC here, it is associated with this VPC restart, right? And this private subnet has now we were talking about route table, right? So if this private subnet, if you go to route table here, and if you look at routes here, routes, you'll see that there's no internet gateway associated with this this private subnet, right? It has NAT gateway, right, which is in the public subnet as another target. So there are only two targets. One is local within that VPC, and another is that NAT gateway that we had created for access to internet. So what that means is that it can reach internet only if only one way, right, from within VPC to internet, but nobody can from internet access this subnet directly. And the same way, if you look at this public subnet and the route table associated with this subnet, and if you go to routes here, you'll see local, and then you'll see the internet gateway associated with it, right? So that means this subnet is a public subnet, and it is accessible from internet as well as the resources within that VPC can access internet. Make sense?
Yes.
Okay. So that's about VPC, creating the VPC, creating subnets within those VPC. Now, once you've created subnet, right, then your public subnet and private subnet, and going back to that example of our website, you can as well go into that. You can, let's say, if you want to create an EC2 instance, right? Your VPCs, restart. Okay. Let's see if you want to create an EC2 instance or web server, right? So, or you want to build a website, right? So you will you're creating an EC2 instance. One second, EC2 dashboard. You can as well come here, launch an instance. I'm just picking something here, create an EC2 instance. And at certain stage, right, during this process, here, it will ask you for which network this EC2 instance needs to belong to. This where you will select your VPC. Okay, I want this EC2 instance or this web server in this VPC, restart VPC. And the next thing it will ask you is, okay, within that VPC, there are two subnets which we have created, right? Which subnet? Look, there are two subnets, right? We had created two subnets there. So which subnets you want the EC2 instance to belong to? Because it's a web server, we want to create have this EC2 instance created in the public subnet, right? Okay, so yeah, we have selected the public subnet. And then, there are other things here like, IAM role and placement group, which is not, which we'll skip for now. And then it will help you. We can instand the launch. We can, launch the instance here. Okay. Here you go. So now this server is created in your public subnet, which is internet gateway associated with. And once the EC2 instance is created, you can have web server in that instance and front end of your website built in that instance, which will be accessible by public. The same way you can go to your RDS service, right? Everybody knows what RDS service is?
Yes.
Right? It's your managed relational database service, right? Now you want to keep your database in your private subnet. So the same way, when you create an RDS instance, again, it will ask you for which VPC you want this RDS to be in, and what subnet you want this RDS or database to be in. And that's where you'll select, okay, I want restart VPC and I want private subnet. Okay. So we have 10 minutes left, but we have gone through a process of creating a custom VPC. We talked about some constructs of it. There is one important construct, which is I would want to just touch upon quickly, is network ACL and security groups. Network ACL, like the name mentions, it's a network firewall that you can create for your subnet. Okay, so if you want only certain traffic to come to your or go from your subnet, then you can create those rules in network ACL. So it will provide you protection or firewall around that subnet for you to further kind of customize what traffic can come to that network subnet and what traffic can go out of that subnet. So any resources within that subnet will follow that rule. And there are security groups. So now, as we discussed, right, within a subnet, you can have multiple EC2 instances. You can even have a database. So there could be multiple infrastructure that you may create within that subnet. What security group allows you to do is, it allows you to create another layer of security around that EC2 instance that you have created, right? So let's say within a subnet, you want a database, right? And in the same subnet, you want a EC2 instance. You want that EC2 instance to be open to other VPCs as well, right? However, you want the database instance to be open to only a set of EC2 instances, and you don't want your database instance to talk with anybody else. So the subnet layer security, which is network ACL, will allow the traffic from all VPCs, will have broader access level, right? Because you want broader access for EC2 instances. However, at the security group level, then you can define that, okay, only certain IP addresses should access my database. However, all IP addresses within my VPC should be able to access my EC2 instance. So that kind of provides you more granular EC2 instance level security for your infrastructure. So these are consider them as two layer of firewalls that you can apply to your within your VPC. Okay. With that, we have 5 minutes left, and I would like to stop here and then see if you have any questions, even if there is something we have not gone through here. And if you have a doubt or a question around it, feel free to ask when it comes to VPC.
Yeah, no questions from me. It's been relatively clear so far. So yeah, it's been a interesting
Okay.
presentation. So no question for me so far.
Sure. Sure.
Uh, uh, Piyush, if you don't mind, can you give me like a brief idea of like the peering connections?
VPC peering. All right. Yeah.
Yeah.
Sure. So, all right. So once you create a VPC, let me see. Yeah, I think there is a 1 second. Once you create a VPC, right, or within a region. Now understand that a VPC belongs to a region. Okay.
Yeah.
Now let's say you have another department. Let's say you have two departments in your organization, right? One works on creating one is database, and another is creates front end services, right? Now those they have created their own VPCs, right, or virtual private network.
Yeah.
In certain cases, right, you may want those two VPCs to talk to each other, right? Those two isolated networks that you've created in AWS to talk to each other. In those cases, you can there's something called peering connection that you can establish between those two VPCs. All right, so that what would happen is if you do not have this peering connection, right? The only way you can communicate between those two VPCs is by going through internet, right? So what you'll need to do is you will need to have a public subnet in one VPC, public subnet in another VPC, right? And then you'll choose an internet route to talk to for those VPCs to talk to each other over the internet. However, you may not want to do that, right? Because it's not very secure, and you still want your instances or your infrastructure to be in private subnet in those two VPCs, but your use case is such that you still want them to talk to each other or communication between those two VPCs on private network, right? So this VPC peering connection provides that private network between the two VPCs, and the traffic still flows within AWS pipeline or backbone to networking backbone to exchange the traffic.
Okay, Piyush, like to more brief, like so you mentioned about the connection, right? So this
Mm-hmm.
connection will help to communicate these two subnets. So it's is it a kind of a set of rules or something, or like what is that connection? Like, is it kind of an
Yeah, so just like you created internet gateway as another rule in route table, right? And then there was
okay?
a NAT gateway related rule in that route table. The same
Yeah.
way in those two subnets, you'll create, if you see here VPX123 and VPX123, you'll create a route or a bridge or a road, right? To
Okay.
tell your traffic or to make sure that traffic goes to that other destination, that VPC.
Okay. Yeah. Yeah. It's
Okay?
more clear. Yeah.
All right. Okay, so we are 2 minutes away. Any other questions? Anyone? Okay, then, thank you very much for your time. It was wonderful seeing you all, and hope this session has helped you a little bit or added to what you have already learned, and you can apply it in real world or to build some POCs and in your account using this session. Thank you very much.
Awesome. Thanks, Piyush, and thanks everyone for attending.
Thank you, Piyush.
Sure.
All right.
Yeah.
Thank you very much, Raj. Thank you, team. And thank you, Bothra. It's been an interesting presentation. And hope to
Sure.
see you next week. Have a good day. And thank you very much once again.
Yep,
You
thank
too.
you.
Bye. Bye,
Bye.
everyone.